Okay, boys, we're going to look at proofs involving numbers. So a couple of things we've got to be aware of. Firstly, an even number can be described by the formula 2n, where n is a natural number. So natural numbers mean that we're looking at numbers which are 1, 2, 3, 4, basically the counting numbers. An odd number can be described by the formula 2n minus 1, where n is a natural number. So if n was 1, you get 2 times 1 is 2, take away 1 is 1. If n was 2, you'd have 2 times 2 is 4, minus 1 is 3. So that generates all the odd numbers. Now, just on the odd numbers, there is another way we can write the odd numbers besides the 2n minus 1. We could say, for example, that an odd number is of this form, 2k plus 1, right? As long as we limit k is an integer, right? K is an integer and k is bigger than or equal to 0. Okay, so you can also represent it like that, as long as you're saying k is bigger than or equal to 0 and k is an integer. So that's for the odd numbers as well. That's another way of doing the odd numbers. Okay. There we go. Odd numbers. Okay, a square number is written in the form n squared, obviously where n is a natural number. And last of all, number x, which is an element of the natural numbers, is divisible by another number, p, where p is an element of the natural numbers too, if there exists a y, where y is an element of the natural numbers, such that x equals py. So in other words, they're saying, if I can divide x by p and get another natural number y, then with no remainder, that means x is divisible by p. Now let's have a look at the first example. Consider two odd numbers, m and n. Prove that their sum is even. Okay, so for this question, we're going to start off by saying, what is m equal to? We're going to say m is equal to 2m minus 1, where m is an element of the natural numbers, right? And the other thing we're going to say is that n is equal to 2n minus 1, where n is an element of the natural numbers, okay? So you have to use different pronumerals. You can't use, what is common? A common error is this. People will go, m is 2k minus 1. K is an element of the natural numbers. And then they'll go n is equal to 2k minus 1. K is an element of the natural numbers. Okay, so this is a mistake because you got the same pronumeral there. You must have a different pronumeral here compared to here. Okay, just like we have here, m and n. Right, so this here is wrong. Don't do it like that. All right, now we've got to prove that the sum is even. So we're going to go m plus n is equal to 2m minus 1 plus 2n minus 1. All right, so that's going to give me 2m plus 2n minus 2. Okay, now we can take out 2 as a common factor, which is 2 outside of m plus n minus 1. Right, and we can say that's equal to 2k if you like, right, where k is equal to m plus n minus 1, and k is obviously an element of the natural numbers, okay, since m and n are natural numbers. Okay, so we've shown that it's of the form 2k, which means that the sum m plus n must be an even number because it's a multiple of 2, isn't it? Right, so therefore m plus n is even since m plus n is a multiple of 2. Okay. And all even numbers are a multiple of 2. Okay. You could have also said that m plus n is divisible by 2, couldn't you? Because you could have said that m plus n divided by 2 is equal to k. You could have also said that. Okay. Let's have a look at the next question over here. Right, so we've got s subscript n is equal to n squared plus n divided by 2. We just rub that out. Hang on. There we go. Prove that Sn minus 1 is equal to n. All right. So let's start off by defining what Sn minus 1 is. That means I replace all the n's with n minus 1. Okay. Divided by 2. Okay, so now you could tidy it up a little bit if you wanted to. We could say, for example, take out n minus 1 as a common factor, and then you'd have n minus 1 plus 1 divided by 2. And then that's obviously going to be equal to n minus 1 outside of, well, that's just going to be n, isn't it? Okay, so we can get rid of that for a minute and just put this as n times n minus 1 all divided by 2. Okay, so that's what Sn minus 1 is equal to. Now, we've got to find the difference between those two, so we're going to now write down the next bit, which is Sn minus 1 will be n squared plus n over 2 minus n outside of n minus 1 on 2. Okay, all right, so we've got a common denominator there, so that's good. So I'll put everything all over 2. And then n squared plus n minus n outside of n minus 1. Okay, and then that's equal to n squared plus n. Now expanding these brackets, you're going to get minus n squared plus n all divided by 2. Okay, and that's going to give you 2n divided by 2. 2's cancel, so you just put that equal to n. Okay, now sometimes at the end of a proof, you can write this, no marks for that, of course, QED. QED is an acronym. It says Quod Erat Demonstratum. Means I have completed the proof as required. It's just Latin. You don't have to put that, but sometimes you'll see that in solutions. Okay, and that is it.